welcome back. So we're still in section 12.3 and we're going to be talking about the squeeze theorem, which I also refer to as the nuclear option. Here's why I refer to it as the nuclear option. The reason is that you should always try all of these things first. So you should try to factor it, you should try to rationalize it. So try factoring it if it's a polynomial, try rationalizing it if you see a square root, find a common denominator if you see a fraction. If it's already factored, try expanding it and canceling, okay? If you tried those things, or if you look at it and you don't see any of those as an option, then the next thing you're going to try is something called the squeeze theorem. Okay, so here is what the squeeze theorem says. It says, if there exists two functions, one called L of x, one called U of x, and one is below our function and the other one's above our function, and they both have the same limit, then it follows that our middle function will also have that limit. Here's what that looks like. Okay, so let's say that we have a limit, let's say it's L. Okay, now what we're going to have is we are going to have a function on the bottom, okay, and it's going to go to L, and we're going to have a function on the top, okay, that's going to be U. All right, and they're both going to get really, really close to L, so they'll meet up like this. And then we are going to have this dorky function f of x, and let's say f of x is always above our lower function but always below our upper function, so it's going to look something like this. Okay. Now the reason it's called the squeeze theorem is because if it's always above L and it's always below U, and then L and U get really, really close here, then what happens is that they have to squeeze our function f of x, and they're all three going to share the same limit. So here's what we're going to do is that we're going to use the squeeze theorem to evaluate the following limit. So we're going to evaluate the limit x squared times cosine of 2 divided by x. Okay? And we want to show that that actually does equal 0. Here's the issue. If you try to plug 0 in, you're going to have 0 times, well, what's cosine of 2 over 0? I don't know. It's undefined, right? You're not allowed to divide by 0. So if you ever have a limit that has a sine or a cosine in it that's kind of giving you trouble like this, here's where you're always going to start. All right, mark my words. Here's where you're always going to start. No matter what you plug into cosine, literally no matter what, cosine is always going to be between -1 and +1. The reason for that is if you graph cosine, and you remember from trig, okay, it always bounces between -1 and +1. All right, so we start off with this fact. Now the next thing we want to do is we want to try to manipulate this so that it looks more like this function. So in order to do that, we're going to multiply the whole thing by x squared. We can do that because x squared is always a positive number, so it's not going to mess with these signs. So we're going to have negative x squared is less than or equal to x squared times cosine of 2 over x is less than or equal to x squared. So we just got done with the first part, which is we found two functions, a lower function and an upper function, that kind of trap our middle function. Cool. Now the second thing we have to do is we have to take the limit of these two and show that the limits are equal. So let's take the limit as x approaches 0 of x squared, negative x squared. That would be 0. Let's take the limit as x approaches 0 of positive x squared, which would also equal 0. Now, since these two limits are 0, and since our middle function is trapped in between them, we know that this is true. All right, let's go ahead and look at a graph and just confirm what we just saw. So we're going to have L of x equals negative x to the second. Our upper function equals x to the second. And our actual function we're looking to looks like this. So if we zoom in, Okay, what we can see is that our function f of x is always trapped between these two, which means that since they both share the same limit of going really close to 0, so does our crazy wild f of x function. How neat is that? Now, for the second part, you'll see this kind of question on your homework and things, is that it says let 2x be less than or equal to g of x be less than or equal to x to the fourth minus x squared plus 2 for all x values. Then we want to use that to evaluate the limit as x approaches 1 of g of x. So the first step in using the squeeze theorem is that you have to have a lower function and an upper function. This problem is actually really nice because they already gave us our lower function and our upper function. So in this case, what we have is we have that 2x would be like our lower function, and that x to the fourth minus x squared plus 2, that would be our upper function. So all we have to do really is double check that the second condition is met. So let's make sure that the limit as x approaches 1 of 2x, well, that would equal 2. And let's see if that matches the limit of our upper function. So we're going to have x to the fourth minus x squared plus 2. So that's going to be 1 minus 1 plus 2, which will also be 2. So since those two limits are the same, then what we would say is therefore g of x, or the limit of it as x approaches 1, must also equal 2 since these two guys are equal. Awesome. So that is how we would use the squeeze theorem. The very last example I want you guys to do is I want you to pause the video and take a whack at evaluating the limit as x approaches negative 6 of 2x plus 12 divided by the absolute value of x plus 6. All right. So what we're going to have to do for this one is we're actually going to have to break it down into two different cases. The reason why is if I plug in 0, or I'm sorry, if I plug in negative 6, I'm going to get 0 over 0, which makes me a little sad. So when we're doing this one, here's what we need to consider. Is whether I'm approaching it from the left-hand side or the right-hand side. So we're going to look at approaching it from the left-hand side, and we're going to look at approaching it from the right-hand side. Okay. So first off, if I factor out the top, I'm going to get x times, or 2 times x plus 6. Now at the bottom, I'm going to have x plus 6. And what I'd really like to do is I'd really like to get rid of those absolute value signs. So here's the deal, is if I take a number less than negative 6 and I plug it into here, if I have the absolute value signs, it's always going to make it positive, right? So if I take values less than negative 6, like let's say that I take negative 6.01 and I plug it in for my x value, that would give me a negative 0.1, for example. So how do I change this mathematically so that it would make it a positive value? Well, if you have a positive, or if you have a negative value, how do you make a negative value positive? Well, you can multiply it by a negative. So if I do that and I cancel these guys out, then what my overall limit's going to be is it's going to be negative 2. Remember, the reason is because if I take numbers less than negative 6 and add them to 6, they're going to be negative numbers. Absolute value will make them always positive, so we have to counteract that by multiplying it by a negative. Now in the next one, if I take numbers a little bit bigger than negative 6, okay, so for example, if I took negative 5.999, remember it's negative, so the smaller the absolute value is, the bigger the number is. If I take, for example, negative 5.999 and I add it to 6, I'm going to get a positive value, so I don't need to multiply by that negative. So if I cancel these guys out, what I'm going to get is I'm going to get positive 2. So if I try to evaluate the limit of this function as x approaches negative 6, 2x plus 12 divided by the absolute value of x plus 6. Well, one side equals negative 2, the other side equals 2, and since I have a limit exists only if the left and the right side agree, this limit would not exist. All right, let's just confirm this using a graph, because I always like to double check my work. All right, so let's let f of x equal 2x plus 12 divided by the absolute value of x plus 6. So as I approach negative 6 from the left-hand side, it looks like my y value is negative 2. As I approach from the right-hand side, it looks like my y value is positive 2. Okay? So because I am approaching a very different number from the left-hand side versus the right-hand side, my limit will not exist, just like I said.